Hi, boys and girls. It's Miss Chase, teaching from my house. So every day I'm going to show you a video of me showing you a few things about what you'll be doing in the math lesson, okay? So when you see this video, it's going to be Monday, March 23rd, and you're going to be responsible for completing a Blue iReady lesson, okay? So as I explained in my previous video, if you watched the one that I'm welcoming you, you're going to go by Mrs. Alder's plans and be doing everything that is due for her. Once you see the assignment on her page, you can then come onto my Google Classroom to see me walk you through the steps and help you with the instruction, okay? So you're doing her assignments and I'm going to be your helper, okay? So today I'm just going to remind you a little bit about what we've learned so far and introduce you to a few other new things about equivalent fractions, okay? So 2 weeks ago now, we started to talk about those. So just as a reminder, we're doing understand equivalent fractions, and I just want to show you, I have a fraction here, right? I would say that this fraction says 4/7. So, and just to remind you, because you're going to be hearing this language, 4 is the numerator. This is how many parts of the whole would be shaded, or how many parts we're talking about. The 7 is the denominator. I remember it's denominator because the denominator is down, okay? And the denominator is how many total parts are in the whole, all right? So to move on to equivalent fractions, the definition of this term is 2 or more different fractions that name the same part of a whole or the same point on a number line. So in that word equivalent, we probably hear the word equal, right? So equivalent fractions means 2 or more fractions that mean the same thing, okay? So I'm going to show you a little bit about that. Right here, I have some equivalent fractions. Let's figure out what they are. So in this first one, I notice there are 1, 2, 3 parts total, right? 3 equal parts in this shape. How many are shaded? 1, 2. So 2/3 of this shape is shaded. Let's see what this shape represents. 1, 2, 3, 4, 5, 6. 6 equal parts in total. How many are shaded? 1, 2, 3, 4. Oh, okay. Now, I know these fractions are equivalent fractions because I can tell by my model. I can see that they have the exact same amount shaded, right? So that's why 2/3 is equal to 4/6, okay? Here's another example. These are circles instead. It doesn't really matter what the original shape is, okay, as long as you're comparing the same shapes. So in this first circle, I see I have 1, 2, 3, 4 total. And how many are shaded? 1, 2, 3. So this first model shows 3/4. In the next model, I'm wondering how many I have in total. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts in total. How many are shaded? 1, 2, 3, 4, 5, 6. 6/8. Okay? So these also show equivalent fractions. I wanted to show you that it doesn't have to be covering up in the same exact spot. Like you notice, we have an empty chunk here and an empty chunk here. That doesn't mean anything, because if I were to spin this wheel around, it would still show the same exact thing. And I notice that 3/4 takes up the same amount of space as 6/8. Okay? You might see another way to do some equivalent fractions here. So let's take a look at this bar. Right now, in this bar, there's 1, 2 total pieces, right? 2 equal parts. One of those is shaded. We don't say 1, 2 though, we say 1/2, right? So 1/2 of this shape is shaded. So say it's my birthday and I want to have half my cake one day and half my cake another. So I say, okay, today we're just going to eat this half of the cake that's shaded. But it's not just me here, I might have some friends. So I'm going to need to cut that up even further. I'm going to cut this whole thing in half. Oh, I just made a new equivalent fraction. Now I have 4 total pieces, and 2 of those are shaded, right? But there's more than 2 of us, so I'm going to have to cut it even further. I'm going to chop this in half and this in half. Notice my shading is staying the same. I'm not reshading anything. But I just made another equivalent fraction. So now how many do I have total? 1, 2, 3, 4, 5, 6, 7, 8. 8 total. How many are shaded? 4. Still, Miss Chase has lots of friends, so I need to cut it up even further. Now I'm going to chop all these in half. Chop, chop. Ooh, I just made another equivalent fraction. Now, instead of counting all these, I'm going to use my math reasoning because I know there's 2 on the side, and I'm just going to count how many are on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 2 is 16, right? I know that like I would be solving an area model. So now I have 16 pieces, 16 equal parts, and 8 of those equal parts are shaded, okay? See how that makes sense? Because I never changed the shading. I only changed the amount of equal parts. So you're going to be seeing that in some of your assignments. The next thing I want to show you is how to use math to calculate equivalent fractions, okay? So I wrote this rule. First of all, I wrote, make equivalent fractions by multiplying or dividing. So here I wrote, you can multiply or divide a fraction by another fraction with the same numerator and denominator to get an equivalent fraction. So this is what I mean. If someone asked you, what is an equivalent fraction for 1/3? You can multiply it by a fraction that has the same numerator and denominator to get an equivalent fraction. So I'm doing 1/3 times 2 over 2, right? Both these numbers have to be the same, which equals 2/6. So I know that's what it equals because when you multiply fractions, it's pretty easy. You can just multiply right across. So I did 1 times 2 equals 2. 3 times 2 equals 6. Okay? So 1/3 is equivalent to 2/6. I could actually even see that up here. This is 1/3 and this is 2/6. Okay? These parts here both show the same amount. Let's look at this one. So I said in my rule I can multiply it by any number as long as it is the same on the top and the same on the bottom. So this time I'm going to multiply by, let's try 5. So I'm going to multiply by 5 over, I hope everyone said 5. 5, okay. So my numerator is the same as my denominator, right? So now I'm going to multiply across. 2 times 5 is 10. I would encourage you guys, if you know the answer, you can say it at home. 10 over 5 times 5 is 25. So here I'm saying that 2/10 is equivalent to 10/25. Okay? Now, let's try one more. And this time I'm going to put a little spin on it. What if someone says, can you find an equivalent fraction to 1/4 that has a denominator of 12? Okay, so you're saying, I need to multiply this fraction by something that's going to equal a fraction with the denominator of 12. This is kind of like a puzzle, right? I already know these two numbers need to be the same. Whatever I do to the top, I must do to the bottom. So what I'm going to ask myself is, 4 times what is 12? My fast math fat kids might be able to get that. Otherwise, if I'm not really too sure, I can use my multiplication chart as a tool. I can drive down my 4. 4 times what is 12? There's a 12. Come over. 4 times 3, right? Okay, so 4 times 3 equals 12. Whatever I do to the bottom, I must do to the top. 1 times 3 is 3. So this means that 1/4 is equivalent to 3/12. They represent the same thing. Okay, the other side of that is you can divide the number, the fraction, by a fraction with the same number in the numerator and the denominator. You're not going to see the division one as much, but if you want to challenge yourself, you could use division to find equivalent fractions, okay? But I do want you to be exposed to it so you're familiar if you do see it in a few problems. So, let's see these ones. The first one I did for us. So, I said 2/6 divided by 2/2 equals 1/3. Well, I know these fractions are equivalent because first of all, my numerator and denominator are the same here, the fraction that I'm multiplying by, divided by, and I divided right across. So I did 2 divided by 2 equals 1. I did 6 divided by 2 equals 3, okay? So I remember when I do division, I'm wondering, how many times does 2 go into 6? So if I was confused about that, I could go down my 2, and I could go to my 6. Oop, there's 6. How many times does 2 go into 6? 3 times, right? And I remember it's like a fact family too. So if 6 divided by 2 equals 3, then 3 times 2 should equal 6, okay? Use your math reasoning here. Check your answer and make sure it makes sense. All right, I'm giving you a little bit of a crazy one because I want to show you how it's actually really easy. 20/70. Well, we need to find an equivalent fraction to that using division. So I'm dividing it by something with the same numerator and denominator. I notice both of these are multiples of 10. I know that because they both end in a 0, right? So I know 10 can go into both these numbers. Okay, let's try 10/10. So 20 divided by 10. You might also say, how many times does 10 go into 20? So I'm going to count on by 10s. 10, 20. 2 times, right? 2 over. How many times does 10 go into 70? Lots of you might know right off the top of your head, but if you didn't, you could count by 10s up to 70. 10, 20, 30, 40, 50, 60, 70. So 10 goes into 70 7 times. So look at that. 20/70 is the same thing as 2/7. Okay? For this one, we're going to do division again to find an equivalent fraction. But I'm going to put kind of the same spin on this one that I did on this one. Someone's going to tell you, you have 4/12. Make an equivalent fraction that has a denominator of 4. So we're going to do something 4/12 divided by something that equals a fraction with a denominator of 4. Oh, okay, here we have this puzzle again. I know these two numbers need to be the same, so I'm wondering 12 divided by what gives me 4? I could also think about 4 times what is 12. If I count by 4s, 4, 8, 12. Oh, 4 times 3 is 12, right? So that means 4 divided by 3, 12 divided by 3 is 4, okay? Whatever I do to the bottom, I must do to the top. Sorry, Miss Chase is making this one up. I meant to say, how many times is 4? You know what? I just confused that one. We're just going to pretend like we didn't do that. Let's just make any other equivalent fraction. So let's do 4/12 divided by 4/4. Okay? This fraction has the same numerator and same denominator. So 4 divided by 4 is 1. And 12 divided by 4 is 3. Okay? That's what I was trying to get to. So 4/12 is the same thing as 1/3. So just a side note, boys and girls, I have had to make a lot of these videos, so sometimes if I make a little mistake, we're just going to kind of keep moving on because I don't want to have to redo the whole thing. So just be patient with me, especially if I embarrass myself, please. Okay, the other thing I want to point out, when you find an equivalent fraction, the reason you can multiply it by something with the same numerator and the same denominator is because this is like multiplying it by one whole, right? If you have a shape that has 3 pieces, here's a circle, this has 3 pieces, and all 3 of them are shaded, 3 out of 3 is 1, okay? That's why we can multiply a fraction with the same numerator and same denominator to find an equivalent fraction. Okay, boys and girls, so you're going to go ahead and do your iReady lesson for the day. Check out what else the teachers have posted for you to do, and I wish you the best of luck. If you need help, feel free to reach out.